Good morning, everyone. So I wanted to do a really short, quick tutorial on limiting reagents and limiting reactants. I know that we kind of looked at a couple different ways to do it. And at this point, I guess I just want everyone to be consistent with the same way that you're doing it. So today, as you're working through your partner worksheet, I want you to use the method that aligns more closely with your method for solving stoichiometric equations. So let's do this problem together using the method that I prefer you to use. So we're given two different quantities, one's in grams and one's in moles, which is not a problem. I'm gonna, and again, I've kind of said in the past, it doesn't matter which one you start with, just pick one, but we're gonna go all the way through. So if I choose to start with grams of hydrogen, I'm gonna do stoichiometry all the way through and to moles of oxygen. So my path is going to be, if I start with grams of hydrogen, and I could have started with moles of oxygen and went all the way to grams of hydrogen, but so I'm going to start with grams of hydrogen. Remember, for stoichiometry, we always have to convert to moles first. So I'm going to convert to moles of hydrogen. Once I'm at moles of hydrogen, I can go right to moles of oxygen, and I'm going to stop there. So remember, each one of these arrows represents conversion factor, conversion factor. So I need two conversion factors to go from grams of hydrogen to moles of oxygen. So beginning with my 25 grams of hydrogen, my first step, remember we said, is to get it to moles of hydrogen. It's H2, so if I look at a periodic table, I know that hydrogen has a mass of 1.00097 or whatever it is. I'm just going to round to 1, but this is H2, so it's actually 2 grams. I want grams to go away, so I'm going to put my molar mass of 2 grams on the bottom, and this is 1 mole, again, of hydrogen. Let me extend that, my hydrogen. So if I stopped right here, grams of hydrogen would cancel out. I'd be left with moles of hydrogen. I don't want moles of hydrogen. I actually want moles of oxygen. So now I'm going to look at my balanced equation. Moles of oxygen compared to moles of hydrogen. So I want moles of oxygen on top. My balanced equation says for every 1 mole of oxygen, I will use 2 moles of hydrogen. And now if we look at this, moles of hydrogen is going to cancel out. I'm going to be left with grams of hydrogen. So now to solve, remember, we kind of always pretend, a whole number is a fraction over 1. So I take 25 times 1 times 1, which is 25. And then I'm going to divide that by 4, which is, 25 divided by 4 is 6.25, if I'm doing my math in my head right. And this is moles of oxygen. And then I just say, okay, so this means if I have 25 grams of hydrogen, I'm going to use up 6.25 moles of oxygen based on this balanced equation. And then I just assess this. Do I have 6.25 moles of oxygen to use up all this hydrogen? Yeah, I actually have more than that. So because I have more than that, it means I'm not going to run out of oxygen. My limiting reagent is actually going to be the hydrogen gas. I have excess oxygen. I'm not going to run out of that. So my limiting reagent is the hydrogen gas. And that is really, I think, the simplest, most straightforward way, and most aligns with stoichiometry, the way that you've done it so far, to predict that limiting reagent. So hopefully that's helpful. I would like you on the worksheet today, please show me that path. Show me this path. I like to see that. And then let's, regardless of which one you start with, convert all the way to the other quantity that you're given. Good luck.